Hello friends, welcome to Truth of Physics. Today I will discuss on the Coriolis force, the expression of Coriolis force in northern and southern hemisphere for a particle moving in different directions. Okay. So basically in this video I will not detailedly discuss on what is Coriolis force, how the expression of the main expression of Coriolis force, that is a minus of a 2m into omega cross v dash. These expressions I will not derive that how this expressions comes, but I will derive that how the expression, what becomes the expression for northern hemisphere and what becomes the expression for southern hemisphere of the Coriolis force. Okay, so this is very important to for solving problems involving this thing. Okay, suppose Earth is spinning about this axis and in this way with angular velocity omega. Okay, so in northern hemisphere, suppose we have a point, suppose here I am in this point or you are in this point on Earth. Okay, just imagine, you have to imagine this. Now when I am standing here, then what is our k cap? We have to define here the three unit vectors, three Cartesian unit vectors, x cap, y cap and j cap, and we set this like this, that the k cap is radially outward from this the point. Okay, this is our k cap, direction of k cap. That means if I stand here, then k cap is directed along this way. Okay, radially straight upward. So if this is the latitude of this point, that is lambda, the angle, this angle. Okay, then if we draw here this, then this angle will be what? Lambda. And now what? Now this is our k cap, direction of k cap. Now we will set the x and y cap like this. Here is our y cap, that is I am denoting it with a j cap. So here it is j cap, means what? Just try to visualize this. Okay, try to realize this, that I am standing here and this is our k cap. Okay, and suppose in north direction is like this way from me. The north direction is like this way. So the north direction, I am in northern hemisphere suppose. So the north direction from me is the direction of local y cap or local j cap. So this is the local north, this is the direction of local north, and this is directed with j cap. So the local south will be what? The minus j cap, the opposite, exact opposite of this. And and to define east and west, we use the x coordinate. So east, so you can easily understand that east will be what? As the three unit vectors are perpendicular, so east will be inward the plane, perpendicularly inward the plane at this point. So it cannot be shown at in this figure as this is 3D. So I am denoting x cap with this. Okay, this is, remind that this is inside the plane. So this is our x cap, this is inside the plane. So this is denoting the x with positive x. I am denoting with the local east. Why local east? As this is our local north. So north here it is north and local east is inward. So you can easily understand that, and all the other things, that local south, local west, you can easily understand that. Now the omega, as we know that the expression of Coriolis force minus 2m into omega cross v dash, that means the velocity in the rotating frame of reference. So this is the expression of Coriolis force. So if Coriolis is this, now so we have to calculate the omega cross v dash. So v dash is given in the question, that the particle is moving in somewhat in direction, that is given in the question. Now we have to express the term omega in terms of lambda. Okay, now we know that omega is directed for omega, the earth is rotating like in this way. So the omega, the direction of omega will be what? This, right? I think you have the basic knowledge. So the omega will be as the motion, as the velocity is in this direction. So the omega will be in positive this way. Okay, so omega is directed along this way. So this is our omega. So if this angle is lambda, then this angle will be what? This is 90 minus lambda, and this angle will also be lambda. So this angle, if this angle is lambda, then I can write that omega for northern hemisphere, omega is equals to omega cos lambda j plus omega sin lambda k cap. Omega is the magnitude of omega vector. Okay, so this is the expression of omega in northern hemisphere. It is quite a simple and quite easy, the expression of omega in northern hemisphere. Now you can easily calculate the Coriolis force using this expression and the expression of velocity as given in the question. Now, but what is the expression of this omega, or what is the expression of, omega for southern hemisphere? In most of the books, the expression is directly written like omega cos lambda j minus omega sin lambda k cap. But how this expression, the expression of omega for southern hemisphere comes? Let us understand it. So for southern hemisphere, this is the case. This is the k cap and this is the minus k cap. Okay, and if this is the lambda, I am denoting it with a lambda dash. For an arbitrary point, the latitude lambda dash. Okay, so this angle will also be lambda dash. Now for east and west, you can easily understand that for east and west the directions will be same as previous. Like this is our x cap, this will also be our x cap in this case, and this is, and for west this x means the inside the board. Okay, and for west the direction of minus x cap, that means towards you, perpendicularly from outward the board. Now you can easily imagine that if a person is in a southern hemisphere, okay, if a person is in southern hemisphere, then what happens to this person? If here it is a person, okay, here is a person, okay, so for this person, what will be the north side? That is for this person, what will be the north and south? You can easily understand that for this person also the south will be in this direction and the north will be in this direction. Okay, so I think that you can understand this. So for this person, the local north pole, the local north, the direction of the local north will be in this direction. So the direction of the south will be just opposite to this. Okay, so if this angle is lambda dash, so this angle will be 90 minus lambda dash, so this is 90 minus lambda dash, and here it is our omega vector. Omega will be same as previous, so this is our omega vector. So if this angle is 90 minus lambda dash, then this angle is lambda dash, and this angle will be again 90 minus lambda dash, so 90 minus lambda dash. So here I can write the expression of omega as omega is equals to the component along this side, that is the omega is equals to omega cos this angle 90 minus lambda, omega cos this angle, omega cos theta, suppose omega cos theta this direction, minus k cap, plus omega sine of the angle, that is 90 minus lambda dash, into this, the perpendicular direction, that is this. So if we solve this, then we will come that omega cos lambda dash j cap minus omega sine lambda dash k cap. As I have written previously, that this is the expression omega cos lambda j minus omega sin lambda k, expression of omega vector for southern hemisphere, and using this you can easily calculate the Coriolis force. So this is the main point that I want to explain in this video. So I think that you have understand what I am trying to explain, And if you like this video, then share this video with your friends, and if you are new to this channel, then subscribe this channel and hit the bell icon to get the latest notifications of my upcoming videos. So take care of yourself. Thank you for watching.